In this video, we return to the topic of optimal work hours. We will evaluate the choice of work hours using the concept of efficiency, and we will also consider how total output is divided between the participants in the transaction. The worker whose choice of work hours we consider is Johan. Johan works on a small plot of land in the Norwegian fjords, which is owned by a local landlord, Oscar. How much grain could Johan produce if we assume he could work up to 24 hours in a day? If we graph grain production against hours of free time, we might get a feasible frontier that looks something like this. All feasible combinations of grain and free time are given by the shaded area, and the feasible frontier shows the most grain that can be produced for any value of free time. On one extreme, to produce 100 bushels of grain, Johan would have to work all the time. On the other hand, if he works 0 hours, he will have 24 hours of free time, but he will also produce 0 bushels of grain. The feasible frontier slopes downward because there's a trade-off between harvesting grain and enjoying free time. To get more grain, Johan has to give up some free time. If the feasible frontier were a straight line, that would mean that Johan produces the same amount of grain for each hour of work. But if the feasible frontier is concave, as it is in this example, then we have declining marginal productivity of labor. As Johan gives up more free time, he produces less and less grain for each hour worked. That's what gives us the curved shape of the feasible frontier. Suppose Johan can always move in with his parents, who would provide him with 20 bushels of grain, which is just enough to survive when he has 24 hours of free time. Then his reservation option, or his fallback option, is just outside the feasible frontier. It represents the grain that Johan could consume if he didn't work. For any amount of free time or work hours, the biological survival constraint shows the lowest amount of food Johan would need to ensure his survival. The survival constraint slopes downward because Johan needs more food in order to work longer hours. The technically feasible set shows all combinations of free time and grain that are both biologically feasible and technically achievable. If grain output is below the survival constraint, Johan will be too anemic to work. Likewise, output levels above the feasible frontier are not technically possible to achieve. At Johan's reservation option, he barely has enough food to survive, but he has 24 hours of free time. Johan's reservation indifference curve shows all the combinations of grain and free time that make Johan just as well off as he would be living at home with his parents, which is his reservation option. The economically feasible set is all the combinations of grain and free time that are both technically feasible and as good as or better than Johan's reservation option. That's the surplus that can be achieved when Oscar and Johan strike a deal. When Johan gives up free time, he needs to do better than merely survive in order to be just as well off as he was at his reservation option. The difference between the reservation indifference curve and the survival constraint represents the compensation in terms of grain that Johan needs in order to be just as well off as he was when he didn't have to work. Where, in terms of hours of free time, is the surplus maximized? Well, it's not maximized where MRT is greater than MRS. Recall that MRT is the absolute value of the slope of the feasible frontier, and MRS is the absolute value of the slope of the indifference curve. At this point, the surplus is not as large as it could be. Likewise, the surplus is not maximized when MRT is less than MRS. Again, the surplus could be larger. The surplus is maximized at the number of hours where MRS equals MRT, so that the tangent lines are parallel. That is where the vertical distance between the feasible frontier and the reservation indifference curve is largest. Given how the graph is drawn, Johann's optimal hours of free time are about 14. In other words, he should work about 10 hours, since 24 minus 14 is 10. When Johann works 10 hours and has 14 hours of free time, he's able to produce about 80 bushels of grain. That's the value of the feasible frontier at the optimal number of hours of free time. He keeps about 35 bushels, which is the value of the reservation indifference curve at the optimal hours of free time. And Oscar gets the remainder, which in this case is 45 bushels. Your numbers may be different, but in any answer, optimal hours should be where MRS equals MRT. The total output is the value of the feasible frontier at the optimal number of hours, and Johann's share of total output is the value of his reservation indifference curve at the same number of hours. So even if you have a different answer, it should follow the same general pattern. Using these numbers, Oscar knows that he has to offer Johann at least 35 bushels, or else Johann would quit and go live with his parents, which is his reservation option. But Oscar also wants to maximize his rental income, so he doesn't want to allow Johann to keep any more than 35 bushels. If Johann turns him down, Oscar knows that he can always find another farmer to take his place. That's why Oscar's take it or leave it offer to Johann is just 35 bushels. Notice that Oscar gets the whole joint surplus, leaving Johann just as well off as he would have been if he were not working and instead just surviving on 20 bushels of grain. That's efficient because MRS equals MRT, but it may not be fair. Johann then learns that he could immigrate to the United States and obtain 160 acres where he could grow 60 bushels of grain per year while enjoying 16 hours of free time. His new reservation option is above his original reservation indifference curve, meaning that it allows him to achieve a higher level of utility than before. It also means that Johann's threat to immigrate and leave Oscar is credible, because doing so would make him better off. Johann's new reservation indifference curve is IC2, and note that it passes through the new reservation option, meaning that it shows all the combinations of grain and free time that make Johann just as well off as he would be by immigrating. Presumably, Johann's fellow farmers are also tempted to immigrate. So Oscar has to negotiate a new deal, or else he could potentially lose all of his rental income. The new indifference curve, IC2, changes the size of the surplus, but the surplus is still maximized where MRT equals MRS, so the tangent lines are parallel. Notice that at the new reservation option, MRT is actually greater than MRS, so the optimal hours of free time is not 16, but rather 14, which is the same as the original hours of free time. And that's where MRT equals MRS. Oscar's new take it or leave it offer to Johann is 68 bushels. That makes Johann just as well off as he would have been by immigrating. And recall that his new reservation option is to immigrate. At the optimal point, Johann still produces 80 bushels of grain and works 10 hours per day, but now he gets to keep 68 bushels so that Oscar only gets 12. Of course, you may have different numbers, but the point is that Johann is now getting more bushels and Oscar is getting less than before. The new allocation is still efficient because MRT equals MRS and the surplus is still maximized. However, the new allocation may also be more fair because Johann's share of the total has increased. To summarize, when Johann's reservation option improved from 20 bushels of grain to 60, he was able to achieve a higher indifference curve, IC2, reflecting a higher level of utility. His share of the crop increased as a result from 35 bushels to 68 bushels out of a total of 80 bushels. Having a better reservation option meant that Johann got a better deal when he came to negotiate with Oscar. Historically, labor legislation and other institutions that improve workers' reservation options often give them greater bargaining power and, as a result, a larger share of the economic surplus. In this example, notice that both the original and the new allocation are efficient, because at both points, MRS equals MRT, that is, all the tangent lines are parallel. The Pareto efficiency curve represents all the points in the feasible set at which MRS equals MRT. So as you can see, many possible divisions of the surplus between Oscar and Johann are efficient. Efficiency ensures that the surplus is as large as it can be, while fairness concerns how the surplus is divided between parties. There can be a trade-off between efficiency and fairness, but this example indicates that it is possible to increase the fairness of the allocations while also maintaining efficiency.